Welcome to The Explainer. Today, we're going to talk about the blueprints of our digital world. I mean, everything from the massive internet backbone all the way down to the Wi-Fi in your house.
So, have you ever really thought about it? How do all these devices in an office, or even just in your living room, actually talk to each other? It's not magic, right? It's all by design. And that design, well, it has a name.
And that name is network topology. You can think of it like an architectural blueprint, but for a network. It's the map that lays out exactly how data gets from point A to point B, spelling out all the pathways and connections.
Okay, so here's what we've got on tap. First, we're going to do a quick tour of the main types of blueprints. Then, and this is the fun part, we'll get our hands dirty with a few challenges to see how this stuff actually works in practice.
All right, let's jump right into Section 1. Time for a quick look at the most common network layouts you're likely to run into.
So you've basically got 5 big players on the field. There's the bus, which is kind of like one single main street that everyone has to share. Then you've got the ring, which takes that street and turns it into a one-way loop. The star is like a central roundabout. Everything connects to that one middle point. Mesh, now that's the fancy one. It's like every single device has its own private highway to every other device. And a hybrid? Well, that's pretty much what it sounds like, just a mix of any of the others.
Okay, challenge time. Let's get practical here and figure out what it actually takes to build one of these things from the ground up.
So let's say you've got 6 computers. Your job is to connect them all in a ring topology. You got to buy the hardware, right? So how many cables do you need? How many connection ports? How do you figure that out without just guessing?
Well, the easiest way to solve this is to start small and look for a pattern. Okay, so with just 2 computers, you need 2 cables to make that loop, right? Add a third computer, and yep, now you need 3 cables. Add a fourth, I bet you see where this is going, 4 cables. A pattern is definitely emerging. The number of cables always matches the number of computers. And, just as important, each computer needs exactly 2 ports, one for data to come in and another for it to go out.
And check it out. We can lay this pattern out in a super simple formula. If you have n computers or nodes, you're going to need n cables. It's a perfect one-to-one match. And because every single one of those nodes needs 2 ports, remember, one in, one out, the total number of ports you'll need for the whole network is just 2 times n.
So there you have it. This little formula is the key. It doesn't matter if you have 4 computers or 400. For a ring network, the cables will always equal n, and the total ports will always be 2 times n.
Which brings us back to our challenge. For our 6 computers, we need 6 cables, and a grand total of 12 ports. See? Super simple once you know the blueprint.
All right, on to the next challenge. This one's about something we all hate, traffic jams. But I'm not talking about cars, I'm talking about your data. Some of these network designs get clogged up way easier than others.
So on one hand, you've got your bus, star, and ring setups. Think of these like sharing a single highway or having to go through one busy intersection. If too many devices try to talk at once, you get a data traffic jam, a bottleneck. But on the other hand, you have the mesh topology. This one gives every conversation its own private, dedicated highway. No sharing needed.
And that's exactly why mesh is the hands-down winner when it comes to avoiding traffic. It's all about those dedicated links. If my computer wants to talk to yours, we get our own private line, and nobody else can get on it. No congestion.
Okay, let's do one more calculation challenge. This time, we're going to look at one of the most common topologies you'll ever see, especially at home or in the office. I'm talking about the star network.
So picture this, 5 computers, and they're all connected to one central device, like a hub or a switch. Sounds pretty straightforward, right? But there's a little catch in the math here that trips people up. And here's the secret. You have to remember the hub. That central device isn't just a box sitting there. It's an active part of the network. So yeah, each of the 5 computers needs 1 port and 1 cable. But that central hub also needs its own port for every single one of those computers.
And what do you know? A familiar pattern pops up again. Even though the physical layout is totally different from the ring network, the math is exactly the same. The number of cables you need is n, the number of computers. And since every single connection uses 1 port on the computer and 1 port on the hub, the total number of ports is, once again, 2 times n.
So for our little 5-computer network, the answer is 5 cables and 10 total ports. That's 5 on the computers and the other 5 on that central hub. Simple.
Okay, we've gone through the blueprints, we've run the numbers, now it's your turn.
You get to be the network architect for what is probably the most complex design of them all.
So here it is, your final challenge. You've got 6 devices. How would you hook them up in a mesh topology? You know, the one that has no traffic jams, but is also the most complicated to set up. The key thing to remember is every single device has to connect directly to every other device.
So think about this for a second. With 6 devices, device number 1 needs 5 cables to connect to all the others, right? Now, device number 2 is already connected to the first one, so it only needs 4 new cables to connect to the rest. You see that pattern? So I'll give you a moment. How many cables do you need in total? How many ports does each device need? And what's the grand total of ports for the whole network? Can you even figure out the formula?
You know, this really brings us to the most important point of all. There's no such thing as the single best topology. It just doesn't exist. A mesh network is fantastic for reliability. I mean, there's a reason the internet backbone uses it, but boy, is it expensive. A star network, on the other hand, is perfect for your home office because it's so easy to manage. It's always a trade-off between things like cost, reliability, speed, and how big you need it to be.
And that's our deep dive into network topologies. But it leaves you with one final question to chew on. What kind of network blueprint are you using right this second? Think about it. The device you're watching this on, it's probably in a star network with your Wi-Fi router sitting right in the middle. But then, that router connects to this huge, sprawling, hybrid mesh thing we call the internet. So chances are, you're actually part of a few different blueprints all at once.